Good morning, I'm John Manier from Accu-Slice. This video will be part 6 of the continuing video series on the development of the Automated Accu-Slice system. Over the past month I've been developing the software for the control and operation of the Accu-Slice system. I've been using two software packages. I've been using a Nextion software package to develop the screens for the system and the Arduino IDE software to develop the software to control the operation of the Accu-Slice system and also to integrate with the screens for the Nextion display. This video describes the status of the system as it's been currently developed. I developed a number of new features into the system which I'll be describing in this video. In the next video in this series I'll be describing the development of the electronics console and the actual operation of the Automated Accu-Slice system using this software. This is the Nextion editor software which I've been using to develop the display screens for the Automated Accu-Slice system. I'm using two screens for the operation of the system, a manual operation or setup screen and an automated operation screen. This is the manual operation or setup screen, which is used to manually control the movement of the stepper motors on the Automated Accu-Slice system. Starting in the upper left-hand section of the screen are the jog buttons for the movement of the carriage holding your board in the linear direction. By pushing and holding these buttons down, the carriage will move continuously to the left or right direction and then stop movement when you stop pressing the button. These buttons are normally used to position your board for the initial or first cut. On the top right section of the display are similar buttons for the continuous movement of the linear X movement of the carriage. By pressing and releasing one of these buttons, the carriage will move in the left or right direction and then are stopped by pushing the stop button in the center of the screen. Notice that under both sets of these control buttons is a box labeled Speed Multiplier. By touching one of these buttons, a numeric keypad will pop up on the screen, which enables you to multiply the speed of the linear movement. When you're first setting up the system to position the board for your first cut, you will probably leave this setting at a multiplier rating of 1. However, when you want to move the board rapidly to the right or left to determine the final position of the board, you will probably want the carriage to move much faster. By setting this multiplier value to a setting of 10, the carriage will move 10 times faster. There are separate speed and multiplier control settings for both the jog and run controls. On the bottom left of the display are the controls to move the dual indexer steppers for the initial positioning of the indexers to position your board next to the bandsaw blade to set up for your first cut. These are again push and release or jog buttons for the indexers. There is no speed multiplier control for these indexers. On the far right side of the display screen are some jog buttons for the individual movement of the two index stepper motors should they get out of alignment with one another. These should not normally need to be adjusted. I originally developed these for the initial testing and development of the system, but I plan on leaving them in the screen just in case you should need to realign the two stepper motors. In the center of the screen, above and below the stop button, are two boxes displaying the axial position of the linear stepper motor and the indexer stepper motors. These displays are for your information. Both of these displays can be reset to 0 by just touching the screen on the top position indicator box. The second screen is for the actual operation of the Automated Accu-Slice system, to either cut a single board or to cut multiple boards in sequence. On the left side of the screen are the 6 setup parameters which you can modify for the boards that you will be cutting. By pushing the screen on any one of these buttons, a numeric keypad will pop up on the screen which will enable you to change any of these values. The forward and reverse parameters are for the forward and reverse speeds of the carriage. The values displayed are calibrated as inches per minute. We have found that we get the smoothest cuts by slicing the boards at a speed between 5 and 15 inches per minute. But when we reverse the board to get ready for the next cut, we prefer to return the carriage much quicker. So this return speed is usually set to a higher value between 20 and 30 inches per minute. The board thickness is the thickness of the board slices that you want to cut. This value is expressed in inches, but could easily be changed to metric millimeters if required. When you type this value into the numeric display panel, you should enter the value in thousandths of an inch, such as 0.45 to cut a board 45 thousandths of an inch thick. The blade kerf is the thickness of the kerf of the bandsaw blade you'll be using. Typically this value is set to 45 thousandths for half-inch rake tooth design blades and 55 thousandths of an inch for 3/4 inch wide blades, but this value can be changed to any other value to more accurately calibrate your system. Again, when updating this value on a numeric keypad, you should enter the value in thousandths of an inch. The board length is the length of the board that you'll be slicing. Normally when we set up a board to be sliced, we position the board about 1 inch away from the bandsaw blade. Later, when you start the automated operation of the system, this initial position is automatically set to a value of 0. So you should set this value to 2 or 3 inches longer than the board you'll be cutting, to allow for board clearance on both sides of the bandsaw blade. This value can only be entered as an integer in whole numbers, and you should always check and double check this value before actual slicing of a board. The final value is the number of board slices that you want to slice from a board. If you set this value to 1, it will just cut a single board and then return to the initial starting position and stop. If you set it to a higher value, it will operate continuously to slice that number of boards. On the right side of the screen is a display for the actual automated operation of the system. There's only one button to be pressed on this side of the screen, the Start Auto Run button. This Start button will begin the actual slicing of the board according to the parameters you set up on the left side of this screen. The rest of the fields on this screen display the operational parameters as the boards are being sliced. The top box is an information field which just displays the current status of the system. The boards cut and remaining boxes display the number of boards that have been sliced and the number that still remain to be cut. The linear, index, and magnets buttons to change color when this particular feature has been activated by the system. The linear position and index position displays the position of the stepper motors at the end of the previous stepper motor movement in both the linear or X direction as well as the indexer or Y direction. These fields are only updated at the end of the cuts and not during the actual cutting due to the limitations of the Arduino software. In addition to these fields, we also have a mechanical emergency stop button and a pause button, which will both be incorporated into the electronics console as separate buttons. Next, I'll briefly describe the Arduino program that was developed for the operation of the Automated Accu-Slice system. This program is currently about 1100 program steps in length, but will probably change when I install the software into the electronics console and start the actual operation and testing of the complete Automated Accu-Slice system. The system is fully documented, and I arrange it in sections or modules to keep it well organized. This first section displays the dates and changes that were made to the software as it was being developed. This next section describes the information for the 3 stepper motors that I'm using in this program. The next 2 sections list and describe all of the buttons, number fields, and information that will enable the Arduino software to communicate with the Nextion display. Next, I'm listing all the variables and data fields that the Arduino software will need to communicate with the software program and operate the Automated Accu-Slice system. This section of the software is fairly long and includes all the routines that are activated when you push one of the buttons on the Nextion display panel. When you press one of the buttons on the screen, this instructs the Arduino software as to what programs or subroutines need to operate, what data needs to be downloaded from the Nextion display panel to the Arduino program, or what data needs to be uploaded from the Arduino program to the Nextion display panel. This section of the software starts the automated operation of the Accu-Slice system when you press the Auto Run button on the display panel. It starts by first downloading the operational parameters which you set up on the display panel to the Arduino software. It next sets the linear and index position to a 0 starting value and then starts the Auto Run procedure in the main body of the program listed below. This setup section of the software contains the information for the operation of the stepper motors, including the speeds and acceleration, and also contains additional information for interfacing the Nextion display panel to the Arduino software. This is the Auto Run and the heart of the program. I organize the operation of the Automated Accu-Slice system into steps or modules. There are 24 steps or modules required for the slicing of a board using the Auto Run procedure. Each of these is numbered on the screen. Each step does one function, such as moving the linear stepper motor, indexing the system, turning on electromagnets on or off, updating a screen on the display panel, and getting ready for subsequent boards to be sliced. Each of the names with the double brackets at the end of the name is a separate subroutine that will run when it is called by the main section of this program. For instance, this first subroutine updates the display panel screen with the starting data. This next subroutine turns the electromagnets off. The display screen is then updated for the starting of the indexing, followed by the next subroutine, which moves the indexer for the slicing of the first board. The various steps and subroutines continue until all 24 steps and subroutines have been completed. I also incorporate a number of other features into these steps, such as the ability to pause the operation at any time and then restart it. I also incorporate safety features into the software, such as Hall sensors at the beginning and start of the linear X direction travel, so you do not run the system past its linear limits. So this is my system I've been using to test the system. It consists of my Nextion 7-inch flat screen display system. Here's my Arduino board. I have 3 stepper drivers and 3 stepper motors. These are 2 that are supposed to be synchronized for the indexer, so they're shorter ones. Then I have a longer one for the linear feed. So these are smaller than my actual system, but they're just used for testing. I also have over here a 24-volt power supply, and then I have an additional 5-volt power supply over here. I have a pause button and a Hall sensor and a magnetic system all for testing. And I do have an oscilloscope hooked up because I've been looking for noise in the system. I was seeing some noise interference, and I was able to isolate that and reduce that noise interference. But you can see some of the noise showing up on the screen there. But this is the system as it's set up. Right now I have 2 screens. This is my manual screen, and here's my automatic operation screen. So again, showing the operation, I have my jog buttons for the linear. And again, if I press it, it moves. If I release it, it stops. Same thing reverse. And this button, if I press the forward and release it, it runs continuously. And to stop it, I just press the stop button and take it back to where I want it. Again, I do have magnifiers on here, so right now these are running at 10 times the normal speed. To change those, I just press the button, so I can delete what's on the screen there, and I can make it, say I want it 15 inches a minute. Just change it and say, okay, now it's running at 15 inches a minute. Same thing over here, I can press that button to change that one, and change it to whatever I want. And this is the forward and reverse for my indexer, which are synchronized. So by pressing and holding this, the 2 move at the same time. If they were to get out of sync, in other words, right now they're both perfectly aligned, but if they were to get out of sync, I can adjust one or the other here just by doing that. Bring them both back in sync and then take them back to the starting position. These fields display the X and Y position. So as I move things, you see I move the linear X. This field gets updated. To zero it, I just press the button and it zeroes it out. And that's the setup display, which you use for setting up your display initially to first do your first cut. When you do your first cut, you want to move the board against the bandsaw blade and then back it away so it's like an inch away from the edge of the bandsaw blade. And that's all done through this screen. When you're ready to run your sample, you press auto run. And here's your 6 parameters you can change. And again, to change just the way you change on the other page, just by pressing a button. Brings up a touchpad. I can change my forward speed to, maybe I want to make it 15 inches a minute. Just change it and say OK, and it changes it automatically there. Same thing, I have my board thickness. Right now I'm cutting a board 100,000 inch thick. I have my forward reverse speeds. I have my board length. I'm cutting a board 4 inches long. I'm only cutting 1 board. I can make that more if I want to cut more. I could delete that and make it say 2 boards, and I'll cut 2 boards automatically. And then to run, all I do is press auto start. So the display up here mentions what it's doing. It's loading. It's actually downloading the data to the system. Now it just moved the indexers in to slide them out. And you see these buttons changing colors as the parts are actuated. As the magnets get activated, it turns it on. When they get turned off, they turn it off. And you saw it just move the indexer forward. Now it moves the indexer back. And now it moves the linear travel back to the starting position. So again, doing the second board, move the indexers in. Of course, my magnets are going off and on over here at the same time. The indexer's moving forward because the magnet's activated. When I finish the cut, it moves the indexer back to move the board away from the bandsaw blade, and then moves the indexer back. So it's all automated. Did that, twice for 2 boards. And here you shows that it cut 2 boards, and there's 0 remaining. And the index or the linear travels back to the 0 position, but my indexers actually moved in 290 thousandths of an inch, for the first 2 boards. Each board went in 140 thousandths, or excuse me, 145 thousandths. 100 plus 45 is 145 times 2 gives me 290 thousandths. This display is displayed in 3 digits, meaning thousandths of an inch. The Arduino software has limitations that it can only deal with integers. And to get these displayed, I had to do a lot of tricks, but to get it here, I really can't do that. So I could have made it digits, but then when you went to over an inch, it would create a problem. So I just left it as thousandths of an inch. So we can repeat it again. Just press, not change any parameters. You get your board lined up against the bandsaw blade where you want it. Get your board length all set. Press auto start. You see it'll update these fields, change it back to 0 here, change this to 0. There's 2 boards remaining to cut. See my magnets went on, linear travels on. Of course the indexer is off at this point. Now the indexer turned on as it reverses. It's cut 1 board and 1 board remaining. The indexer was at 45 thousandths of an inch on the indexer system. I have 2 other features that I actually spent quite a bit of time developing. One is a pause button, and the other is a Hall sensor button. Let me go to the manual operation to show this more clearly. Move my jog back to a further position. And let me slow the speed down. Okay. So this is, first of all, this is my pause button. It's a momentary button that latches. And if I'm running a board, say I was just running a board continuously, which my board's running, and if I press the pause button, it stops dead in its tracks. I push it again, and it picks up right where I left off. And this works in any part of the program, any of the automatic operation of the system, anything. It just press it to stop it, press it to go forward, it picks up right where I left off. This system works very nice for pausing the system anywhere in the program. The other feature we have is the Hall sensor. And the way this works, if the travel on the linear X system exceeds the length of the rail, it'll hit this Hall sensor and then stop the program automatically. So this is the Hall sensor. It has a sensor here, so when it senses a magnetic field, or when it senses a field, it'll activate the system. You see that red LED went on. So I can actually show this. We can, let's run it forward. So it's running. I move it against it. Stop. It stops it, actually moves it back away from the Hall sensor. So that works nice too. But it took a while to develop both of these systems, both the pause button and this stop system. And that works on both ends of the rail, both left and right sides of the rail. Okay, that pretty much completes the testing of the software that we developed so far. I've spent a good 4 weeks developing this, getting all the bugs out and getting everything worked the way I want. So the next step is to actually build an electronics console. I'll put all these components in a actual box with connectors to the system, and then actually operate the Automated Accu-Slice system. So that'll be shown in the next video. Once again, thank you for watching this video. If you have any questions or comments or concerns, as always, please give us a call or drop us an email. Especially if you have any ideas on how we can improve the system, what additional features could be put in, we'd definitely like to hear from you. And once again, thank you for watching.